so in problem 33 we are reviewing we're using the Q that we just talked about in class today. And what it asks us is it gives us an equation and it tells us that the equilibrium constant for this equation is equal to 2.4 times 10 to the third. So when this reaction is at equilibrium, the ratio of the products to the reactants is going to equal this number. And then it gives us some values for different periods in time. And it tells us that it's a 1 liter flask and it has 0.02 moles of this, the reactants, and it has, 0.024 moles. And then it has 2 moles of N2 and 2.6 moles of O2. So the first thing I notice is that I'm given moles and not concentration. But in this problem, the concentration is the volume is 1 liter. So the concentration is just going to be actually the same as the moles. So what we get here, we're going to calculate a Q, and we're going to see that we have products. So we have 2 moles divided by 1. And we also have 2.6 moles divided by 1 over the reactants. So we have NO2, which is 0.024, and that's over 1, but this one's raised to the second power. So now when we calculate this Q, we're going to see that we end up with 9 times 10 to the third. This number is way bigger than that number. So in order to reestablish an equilibrium, since this is big, we need to increase the amount of reactant. Okay, because by putting a bigger number down here, it's going to lower that ratio. So, or another way to write this is Q is greater than K. So shift to make more reactant. Oops, you can't really see that. But trust me, it says, there it is, reactant. Alright, so I'm going to also do B for you just to make sure you really got it. And B gives us some different values for moles, and it gives us also 2 liters. So we're going to use the same products over reactants, but I have new numbers. So this is going to give us products 0.62 over 2. And you should use brackets here. And we also have 4. We also have 4 over 2. And the last one is 0.032 over 2 raised to the second power. And when we calculate this one, we actually see that Q is equal to 2.4 times 10 to the third. So Q equals K, so this represents a system at equilibrium. And I bet you can guess it, but in the next one Q is going to be less than K, because that's how it is. We felt like we had to give you one of each. So I hope that helped for number 33.